So before we begin our class today, I thought that I will show you the demonstration that I promised you the other day, okay, which has to do with resonance and also the word parabola. Remember we talked about. I know today is supposed to be apa ulang kaji, okay, but I just want to show you this demonstration while we wait for the rest to come in lah. So that the rest they come in late lah. Okay, so those who are early is like yay, okay, we can see another demonstration. So we talked about the word parabola, okay, and how the shape of the parabola actually helps with the reflection of waves. Okay, so the shape of a parabola, the word parabola, P-A-R-A, and then after that bola. Okay, the word parabola is actually a combination of two words. Okay, para for the word parallel, okay, parallel, and then bola is for the shape of the bowl. Okay, so it is actually a bowl, okay, with a parallel component to it. Okay, so I have here with me, and one of the best shapes of a parabola is what we call the wine glass. Okay, it's just water in here. Okay, don't even think anything. So this is just water. Okay, so I have two wine glasses here. Okay, just to show you that I'm drinking a lot of water. Okay, it's really water. Okay, so the word parabola. Okay, so down here is the bowl shape, and then you find that up here is kind of parallel. Okay, it's kind of parallel. But the good thing about parabola is that, and you will learn this later also in chapter 6, is that actually it is a very good reflector. Okay, it is a very good reflector, and when sound or anything reflects, it always reflects to a certain point which we call a focal point, okay. But usually we tend to use this kind of glass, and I think you may have seen this demonstration before. Usually we tend to use the parabola. It works best with a parabola. A bowl also can, but needs a little bit more effort. Parabola is really the best, okay, to show the effect of resonance. Okay, remember resonance is you're forcing something to vibrate at its own natural frequency. Okay, so I hope you can hear this. So I have this glass. Sorry, let me bring this down here. Okay, so I'm taking this glass. Yeah. Okay, fine. Ignore my this one, okay. So I'm taking this glass and I have to make sure that my hand is wet. Okay, my fingers are wet. And so when I rub this, okay. Sorry, I don't know if you can hear that. If you cannot hear that, please let me know. It's like apa ini? So Marcus is rubbing the glass, but there's nothing happening. Okay, so let me show you again. So when I rub my wet hand, okay, so I will produce a certain sound, which is what I'm doing. Is I'm making this glass vibrate at the same frequency as this water. Okay, and you know why I say is this water? Because, okay, so this is the second glass. Let's compare these two glasses. You see that this glass on the left here has significantly less water. Okay, significantly less water. And so the amount of water, okay, the amount of water actually tells us the kind of frequency this is. Okay, so again, the original one with a lot of water is what it sounds like. Can you all hear? Can you all hear the woo woo woo?
Can.
Okay. So this is a lot of water. Okay, and then if there is less water, this is what it sounds like. Let me ask you: do you think that the sound will be lower frequency or higher frequency sound? Less water. Lower frequency means low, and then higher frequency is high. What do you think?
Higher.
Higher frequency. High frequency means you're expecting to hear a higher pitch. Okay, let's see lah. Since only Ethan answered, I'm just going to layan. Okay, so you find that actually my dog is staring at me. It's like, what am I doing? So you find that with less water, okay, the frequency is higher. It's a much higher sound compared to this one, which is a lower one lah. Okay, so if you remember the glasses that I showed you that day, remember the glass orchestra thing, right? So this is basically how it works lah. The most important thing is your hand needs to be wet, and secondly, the shape of this thing At best lah, okay, at best lah, it should be a parabolic shape. Okay, it should be a parabolic shape so that you can get the resonance effect lah. Okay, you can have the two sounds together. Wow, here I'm trying to be mau cuba lah konon jadi apa? I want to be like the orchestra player. Okay, so uh, so um, yeah lah. So that's the demonstration. Yeah lah, so that's the demonstration to show the effect of resonance, and actually the more important thing is to show the shape of the parabola. I think it's very interesting that the word parabola comes from two words lah. It's a parallel bowl. Okay, so the sides are parallel, and then there's a bowl lah. So even a big bowl lah. Okay, like I know, like last time when I was in school, I used to go to this shopping complex where and there's this seller at this shopping complex, and she sells crystals lah. And so one of the ways she attracts customers to come to the shop is to just do this demonstration lah. But she has this huge bowl, Okay, it's about this big. It's all as big as my shoulders lah. Okay, so it's this huge bowl. But interestingly, it is not a bowl like the normal kind of Chinese bowl. No, it is really a parabola. It's parallel, and then only it curves at the bottom. Okay, and then she used to do it so 夸张 lah, very 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 melebih-lebih like, wow, just to show that sound. But it was her way of attracting customers to come to the store lah. Okay, to buy crystals for whatever purpose lah. Okay, some people believe in the healing power of crystals. It's pretty interesting, actually. All right, so let's begin. Let's start our revision class. Okay, now that the 10-minute demonstration on Friday morning is over. Okay, the only way, the only way to while we're waiting for people, the only way to waste time, no, to kill a little bit of time. Okay, so let's take a look at this. So what your class have decided is to do a little bit of revision, okay, on force and motion. So today we're going to do force and motion. Then next Friday we're going to go into gravitation. Okay, so we're going to cover as much as we can. This is from the Form 4 module. Oh no. Okay, this is from the Form 4 module that actually is from JPN Sabah. Okay, and yeah lah. Okay, so let's go to this page. Oh no. Okay, so diagram 1.1 shows a feather and a plastic ball released from the same height. Okay, and the velocity time graph you see, okay, it's always this lah. Okay, let's first talk about the two graphs that you're supposed to know. Okay, and what the interpretation is lah. So the first graph is the displacement time graph. Okay, the second graph is the velocity time graph. Okay, there are two graphs that you need to know, and every graph has a different interpretation, has a different explanation for the motion, and you cannot confuse between the two lah. You should not confuse between the two. Okay, if it is a displacement time, then you talk about displacement time. If it's a velocity time, velocity time. Now, a displacement time graph, okay, generally lah, okay, it will look like this. Sorry, there are three types of motions lah. Okay, so, oh no, okay, sorry. I'm going to draw this in blue, blue, orange, and I think the third one I'm going to do pink. Okay. Sorry, the pink and the orange looks very similar, lah, but fine lah. Okay, so how do you know that it's a displacement time graph? Because of the letters S and T. Okay, sometimes if the question doesn't tell you what kind of graph it is, at least you know stands for displacement. Okay, and so the ST graph is a displacement time graph. It's a graph that shows you, okay, it's a graph that shows the position of object at any time. And this is a very important thing for us to understand. It only tells you the position only. Okay, it doesn't tell you, whether it is going faster or going slower. It does, like it does, but it doesn't really say. The displacement time graph just tells you, oh, okay, at this particular point in time, it is at this position. Okay, let's say 2 meters. At this particular point in time, oh, sorry, let's say this is 2. At this particular point in time, okay, uh, let's say this is 10 seconds, like this is 5 seconds. Okay, so at the 10th second, the object is at 5 meters away, okay, from the starting point. So it shows the position of an object from the starting point, okay, from the starting point O, 0, okay, at any time. This is a very important thing, okay, for us to understand. Because the starting point O, if this is O, okay, if this is the starting point O, anything towards the right now is positive, the positive part of the graph. Okay, means the entire position is at the right. Okay, and anything towards the left is a negative part of the graph. So it may actually go down here even more. Lah. Okay, but I'm not going to go there. Lah. Okay, so when we understand what does the displacement time graph means, okay, it helps us to visualize the movement better. Okay, now blue color part, this blue color section, okay, the blue color section means that the object is moving towards the right. It is moving away from this one towards the right, assuming that positive is the right. It's moving away, moving towards the right. Okay, but the more important interpretation is this. Besides the fact that it is moving to the right, okay, the object is moving with constant velocity. Okay, why? How do we know that it is moving with constant velocity? Okay, because in a displacement time graph, okay, in a displacement time graph, the gradient, okay, when you calculate the gradient of the graph, okay, it shows you the velocity. Okay, so this is the only two information that you can get from the displacement time graph. Number one, it tells you the position. Okay, dia di mana, dia di mana, dia di mana, with respect to the starting point. Number two, when you calculate the gradient of the graph, it tells you the velocity. So if you calculate the gradient idea, okay, and then the gradient is 2 lah, okay, then you know that the velocity, the average velocity of that movement is 2 meters per second. Okay, if the gradient is 0, okay, in this case, okay, so in the case of the orange, I'm going to talk about the orange line now. The orange line now, the object, take a look at this. I said already just now. Displacement time graph shows you the position. And since this entire time, okay, from this time until this time, okay, the object is at the same position. If something is always at the same position, is it moving or is it not moving? I repeat the question now. If something is at the same position, is it moving or is it not moving? Think logically, nothing one. This is logic. If you're always at the same position, right, are you actually moving or not? Of course, you're not moving because you're at the same position. Okay, so object is stationary. Okay, reminder, the word stationary is spelled with the letter A, not the letter E. Okay, so object is stationary, or another word for stationary is at rest. Okay, that's why if you calculate this gradient, you're going to get the gradient equals to 0. Because, it's flat, it's not even condong, tiada condong langsung. Okay, gradient is kecondongan, this is not condong at all. Okay, so in terms of velocity, it will be 0. So the object is at the same position, it is not moving, it is stationary. Okay, and the last one is the pink color one. The pink color one is going down this way. Okay, now This is a slightly complicated one, but let's go to this. Number one, we find that the object, if the blue color one, the object is moving away from the zero position. The pink color one, the object is moving towards, oh no, sorry. Okay, the object is moving towards the zero position. If this is going to the right, if the blue color is going to the right, so the pink color must be object is moving. Oh no, sorry, hold on. The object is moving in which direction? The object should be moving to the left. And should it not be moving to the left? Yeah, object is moving to the left. Okay, object is moving back to the zero position. This is the zero position. Okay, at the zero. Okay, so 0 towards 2 towards 5, and then after that come back down towards 0. Okay, but because the gradient is this way now, okay, the gradient is this way, it is moving also with constant velocity. It is just that it is moving to the left. Okay, so in the case of the blue color line, the constant velocity is a positive velocity, because positive tells you the direction. Okay, moving to the right, whereas the pink color one, it is coming back to the zero position. So it is constant velocity, but the velocity will be a negative value. Okay, so this is the displacement time graph in a nutshell. Sorry, I'm babbling on for this one. Okay, displacement time graph in a nutshell, this is basically it. Now the velocity time graph, sorry, this is ulang kaji lah, so I'm just going to ulang kaji as much as we can. Okay, velocity time graph tells us a different thing. It tells us, okay, it shows, okay, the velocity, okay, of an object as it moves. Okay, it doesn't tell you where it starts and where it stops, but we always assume that it starts from a 0 point, okay, from t equals to 0. But it shows you the velocity only. Okay, and so if I draw the same graph, okay, if I draw the same graph, okay, v against t, because it's velocity, okay, the shape of the graph is the same, same shape of the graph, but the meaning is entirely different because the velocity time graph tells you the velocity. It doesn't tell you the position. Okay, it tells you the velocity. And in this one, we can see, oh, sorry, you know what? I'm going to do blue color again. This blue color, orange color, and pink color. Okay, so for the blue color line, okay, it is increasing velocity or constant acceleration. Okay, because in the velocity time graph, two very important pieces of information. The gradient, okay, when you calculate the gradient of the line, you are calculating the velocity. When you calculate the area under the graph, okay, you are calculating the distance traveled. ELLED. Okay, you're calculating the distance traveled. Now, when I say area under the graph, it depends lah. Okay, it depends on whether you want to calculate the entire area like this. Okay, and if you look at the shape, it is a shape of a trapezium lah. Okay, or if you're only interested in a certain section of the this one. So, for example, I put a boundary here, and then I only want to calculate this area where it is increasing velocity. Okay, so the shape of that graph will be a triangle, and then this particular area will be, okay, the distance traveled. Okay, but I think a third piece of information that a lot of people tend to miss out, okay, is the position, okay, of the graph. Okay, the position of the graph tells you the direction of motion. Okay. Now, if you take a look at this, all your V is positive value. Okay. So a positive V means that object is moving to the right. Okay. In this case, this graph that I'm drawing, the object is only moving towards the right. It's forever moving towards the right. Okay. Yes, it is forever moving towards the right. And if I were to draw, okay, if I were to draw, this is the car, right? Okay. So for this blue color section, now object is moving. For this orange color section, the object is still moving. And for this pink color section, the object is still moving towards the right. Simply because the position of the velocity graph is on top of the x-axis. Okay. So when the negative velocity, when the velocity becomes negative, then the object is moving to the left. And this is something that a lot of people tend to miss out, especially VT graph. Because sometimes, okay, let's say the velocity time graph like this. Okay, so like that, and then like that, and then like that, like that, like that, like that. let's say lah. Okay, now, so okay, this one, object is always moving towards the right. Okay, but the blue color ones, this one, object is moving towards the left. But when I say move towards the right and towards the left, it doesn't mean that it go back to the zero position and then move towards the left. No, nothing to do with this. Okay, the displacement time graph always tells you when you start from the 0 point. Okay, so if it is positive, then it's moving this one. But then after that, if it goes back to zero, and then after that, it moves to the left. But velocity time graph, okay, doesn't show you the position. It only tells you whether it's moving to the right or moving to the left and how much is the velocity. Okay, so this one, okay, how would I imagine this motion? Okay, let's say this is the starting position, 0. Okay, this is the car. Okay, pink color section, increasing velocity, move to the right. Okay, 1. Okay, 2. Decreasing velocity. The velocity is getting less, but it's still moving to the right. So move to the right some more. 2. Okay, 3. It is increasing velocity, increasing negative velocity to the left. So this one is patah balik. 3. Okay, this one is decreasing velocity. Wow, sorry. Okay, decreasing velocity, but to the left, 4. Okay, so that's what this means. It doesn't mean that if it comes back to the 0 position, means this car magically jump back. No, it's not what it means. It just shows you whether it's going faster, going slower. That's it. Doesn't tell you the position. Position graph only tells you the position. Okay, so when we describe the motion of the graph, okay, we need to remember these two things. Sorry, my mistake over here. This is not velocity, this is acceleration. The gradient of the graph actually shows you the acceleration. Okay, that's why the blue color line is increasing velocity and constant acceleration. And this is a very, very important thing. Whenever you write the motion, I want these two to always come together. Okay, make it a habit. When you say increasing velocity, immediately I want you to think of constant acceleration. Okay, so and I will tend to ask this from time to time. Increasing velocity, and also so you must know that increasing velocity, the partner is constant acceleration. Okay, make it a habit to write these two together. Okay. Oh no, hold on. Okay. So second one is the orange color line, flat like this. Okay, this will be constant velocity. Is it moving? Yes, it is moving. It is still moving. If the displacement time graph flat like this, right, is not moving because the position doesn't change. But for the velocity time graph, the velocity doesn't change. If it is moving, it is still moving. Okay, but with a constant velocity and zero acceleration. And so this also comes as a pair. If you say constant velocity, you must say zero acceleration. If you say zero acceleration, you must say constant velocity. I'm taking half an hour just to explain this entire thing. Oh no, we're never going to finish this. Okay, flat down like this. This will be decreasing velocity and constant acceleration to the left. Okay, I just want to mention this now. No, sorry. No, sorry, my mistake. Not constant acceleration to the left. Constant deceleration. You know what? Okay. Constant deceleration. Okay, deceleration means going slower and slower. Decreasing velocity lah. Okay. So in terms of acceleration, there are only two words, either constant or zero. Okay. For velocity, it will be increasing, constant, and decreasing. Now, finally, coming back to the question. Okay, so this is a velocity time graph, but a little bit weird lah, because it looks like this. There's this curve over here lah. Okay, so first of all, name the two forces acting on the feather and the plastic ball. Okay, this is a very natural one. The force going downwards will be gravitational force. Okay, otherwise known as weight. Okay, and then if there's a force downwards, there will be a force upwards. Okay, and naturally the force upwards will be air resistance. Okay, this everything that moves on Earth will always be subject to these two. Air resistance or friction if it is this one. So the two forces will be gravitational force and air resistance. Okay. Secondly, explain the motion. Okay. So this is a very important word now. When we say explain the motion, okay, I'm referring to these words. So you need to know the key words for this. Increasing velocity, constant acceleration. Constant velocity is zero acceleration. Okay. If it is a displacement time graph, explain the motion. Then we say this. Object is moving, blah, 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 blah. Okay. So in this case is probably something that I haven't explained. Okay. We know that this flat line, we know that this flat line over here, okay, means constant velocity. Okay, we know that lah. Okay, but I didn't explain to you just now. What if the line is a curve like this? Okay, so if the line is a curve like that, okay, it will be increasing velocity. Okay, because the velocity is increasing. Okay, but because it is curved like that, okay, increasing acceleration. It is going to get astaga, not acceleration, acceleration. Okay, so it's going to get faster and it's going to get faster and faster. Sorry, faster and faster. No, sorry. Wait, hold on. Oh, this one. Sorry. If it is this one, and then it becomes flat. Okay, sorry, this constant velocity, zero acceleration. Sorry, this will be decreasing acceleration because the shape of the graph is like that. Yeah. Okay, so decreasing acceleration until velocity is constant. Okay, so the velocity will increase, but the acceleration will decrease until it finally becomes constant. So if the graph is like this, this is decreasing acceleration. But if the graph is like this is very rare okay. I'm a little bit sad that we have to start with such a difficult question. Okay, this one is increasing acceleration. Okay, this will be increasing acceleration. So it depends on the shape of the graph lah. But this one, okay, is generally a decreasing acceleration because finally it's going to become constant velocity. Okay, is it still moving? Yes, it is still going to move, okay, until the velocity hits zero. So which object will reach the ground first? This one logic will tell you lah. Okay, which one? Do you think the feather will reach first or the plastic ball? Okay, obviously it's the plastic ball lah, because it has a higher velocity. Okay, so it will be the plastic ball. Okay, it will be a plastic ball, and then why? Okay, why will the plastic ball reach first? Okay, although, yeah, why will the plastic ball reach first? Okay, because there's less air resistance acting on the ball. Because the ball is so tiny, not to say tiny lah, okay, but there's less air resistance lah. Okay, there's a smaller area for it to travel, so it will definitely not experience so much air resistance as compared to the feather. Feather is so big. Okay, so more air resistance over there. Okay, the feather and the object are now dropped in a vacuum. Okay, so originally it is dropped in air lah, okay, on Earth. But in a vacuum, and when we compare the motion of the two objects, what we're going to get is they're going to have the same acceleration. Okay, or the same velocity. Okay. So when you compare motion, you always want to talk about, acceleration, velocity, displacement, and this kind of answers lah. Okay, so same acceleration, same velocity. If you're even if you want to make your answer a little bit more lihai, so you can say the acceleration is 9.81 meters per second squared. Because in a vacuum, the acceleration is constant. Okay, in a vacuum, both the plastic ball and the feather will drop at the same time because there's no air inside vacuum, so there's no air resistance. The reason why on Earth, if you drop a plastic ball and a feather, the plastic ball will definitely fall faster because there's less air resistance acting on it. Okay, the feather, a little bit of air push here, push there, push everywhere, then dia akan terumbang ambing sini sana. But in a vacuum, there's no air. No air, no molecules to push either of the plastic ball or the feather, it will actually drop at the same time. Okay, so, sorry, one question, half an hour. So diagram 2.1 shows a ticker tape. Okay, ticker tape, let me just briefly go through this. Ticker tape shows you a few pieces of information. When the dots are near, the velocity is small. Okay, when the dots are far apart, then it is a high velocity. Okay, so that means if it is first near and then go far, like that, this will be increasing velocity. And then if it is far, and then after that become near, this will be decreasing velocity. The best way to think about this ticker tape graph, okay, or ticker tape, this one, is to think as if the car has a leak at the back. Okay, so let's say you have a car, okay, and then somewhere at the back here is leaking oil. So as the car is moving, okay, the oil dots will tell you whether it's moving faster or moving slower. Okay, so if you ever find yourself confused with the ticker tape, okay, my suggestion is you think of a car and you think that there's a hole in the gas tank. Not a very good thing to have. Okay, but you think of a hole in the gas tank, and as the car is moving, the oil will drop at a steady rate. Okay, so in this case, you'll find that over here is near and over here is far. The dots are far apart. So we're talking about increasing velocity. This object is moving with an increased velocity. Okay, so complete the sentence below. This one, I think it's just a fact. We need to use alternating current, okay, for ticker timer. Because if we use direct current, the ticker timer will not vibrate. Okay, on the diagram above, mark X to show one tick. Okay, one tick, one tick is the distance between two dots. Okay, that is a tick. That's why it's called a ticker timer. Okay, that's why it's called a ticker timer, because it produces ticks. Okay, not the ticks that you find on a dog or cat, not that kind of ticks, but ticks lah. So ticks are, tick, okay, is a distance between two dots. You know what's dots? Dots lah. Okay. So one tick is the distance between two dots, very, very similar to our wavelength that we've been discussing. Distance between two crests, distance between two troughs, okay, distance between two compressions, same thing. One tick is the distance between two dots. So based on the diagram, determine the velocity of the trolley. Okay, so we're going to use this. Wow, this is such a... Okay, fine. We're going to use this. But one thing that we need to know, okay, which they're not telling you over here, okay, one thing that we need to know is that the time between two dots, or the time for one tick, is 0.02 seconds. I think this is something that they never mentioned. Okay, but actually, by right now, you're supposed to know this. Okay, it's like a factor. So if you don't know, then that's it. You cannot answer this question, but you should know. Okay, that the time for one tick, okay, is, so time for one tick is 0.02 seconds. Okay, now velocity is the displacement or the distance, okay, over time. Okay, now the displacement is 5 cm as given over here, and there is, how many ticks are there? There is 1, 2, 3, 4, 5. So if one tick is 0.02 seconds, 5 ticks will be 5 times 0.02. Displacement is 5 cm. Okay, you can use cm if you want, or you can change it to meter if you want. Okay, but when you calculate this, what you will get is, I think it's 50. Okay, 50. But because we're using cm, so we use cm per second. Okay, centimeters per second. If you want to have it in meters per second, then you make sure you change this 5 cm to become meters. Okay, doesn't really make any difference. You still get the same answer, just a different unit. Okay, you get 0.5 meters per second. All right. Okay, number 3, hot air balloon floating at rest in the sky. This, hey, hold on. This is not, sorry, this is not your question. Sorry, cannot. Okay, I want to do this question. Okay, as a researcher, you are asked to investigate the characteristics of a car to be modified into a racing car. Wow, doesn't it sound familiar? Okay, what is meant by velocity? This is a very standard definition. Velocity is the rate of change of displacement. Okay, now the words rate of change of comes because the formula for velocity is displacement over time. Okay, so this one, over time, in definition, we always call this the rate of change of. Rocco lah. Okay, rate of change of. So if it is rate of change of displacement, that will be velocity. Acceleration is v minus u over t again. Okay, there's the over t. So acceleration will be the rate of change of, and what is v minus u? Velocity. Okay, so this is acceleration. So acceleration is the rate of change of velocity because the formula tells us that it's over t. Velocity is the rate of change of displacement because over t tetapi di atas adalah s. Okay, so the formula sometimes helps us with the definition. Okay, rate of change of. All right. Now, a car is moving with a uniform velocity. I'm going to highlight this first. Brought to a stop when a driver sees an emergency signal for stopping. So sketch a velocity time graph for the motion of the car and explain the changes that occur and how the braking distance is determined. Okay, this will be good for us to revise lah. So first of all, we need to draw the graph. Okay, let's draw the graph first. Okay, so the graph will be, at first he's moving with uniform velocity, constant velocity throughout. Okay, so the velocity time graph, constant velocity means he's moving with the same velocity lah. Okay, not changing velocity. Is he moving? Yes, he's moving, but he's just moving with the same velocity. Okay, it's brought to a stop when the driver sees an emergency signal for stopping. Okay, so it will be like that lah. So finally, it stops. Okay, so this is the shape of the graph that we are thinking about lah. Okay, it will be like that. Okay, now, next one is explain the changes that occur. Okay, explain the changes that occur means you have to talk about the motion lah. Okay, so I would suggest that when you want to do something, you divide it into two parts. Okay, divide into T is A and T is B. Okay, so from T equals to 0 until T equals to A, whatever this time is lah. Okay, from T equals to 0 until T equals to A, the car is moving with constant velocity. And what is constant velocity? Sorry, my dogs are awake. The car is moving with constant velocity, and what is constant velocity's friend? Always comes together with zero acceleration. Okay, and zero acceleration. Okay, this is 1 mark. The graph is 2 marks lah, 1 mark for this one. Okay, so from T equals to 0 and T equals to A, there's one section. Okay, the car is moving with constant velocity and zero acceleration. Let's talk about from A to B. So from T equals to A until T equals to B, the car is moving, is still moving, okay, with decreasing velocity. Okay, and what is decreasing velocity's friend? Let's take a look. Decreasing velocity, the friend is constant deceleration. Okay, and constant deceleration. Sorry, my writing. Okay, and this is another mark. It's a 5 mark question now, but I just want to show you how the marks are divided. So 2 marks for the graph. Okay, 2 marks for the explanation, but there's still another mark. The 5th mark is how the braking distance. How do you determine the distance? Okay, how do you determine the distance of velocity time graph? Okay, that's why the information I gave you just now is very important. The distance is area under the graph. Okay, so your fifth point, and I got no space to write now, so I'm just going to write it here. Okay, the braking distance. Okay, the braking distance is determined by calculating the area under the graph. Okay, but for which section? Okay, the area under the graph of this one, because only this one they start to break bakan. Okay, the area under the graph from T equals to A until T equals to B. That's your 5th mark. Okay, the braking distance is determined by calculating the area under the graph from T equals to A until T equals to B. Okay. Sorry, T equals to A until T equals to B. Only this way. Because this one is not braking. Okay, if the question say how do you determine the total distance, then okay lah, you just calculate the total area lah. Okay, so again, the point that I mentioned earlier, which is actually a very huge chunk in your chapter 2, is this one. Okay, talking about the graph. So it would be a good idea for you to, to go and revise about the graph. Okay, so let me hold on now, just give me 1 minute. Okay, so I'm going to answer question C. Okay, when an airplane is landing, okay, the velocity is 50 meters per second. The deceleration of the plane is 3 meters per second squared. What is the minimum length of the runway needed for the airplane to stop? Okay, now this is the equations of motion question. Okay, let's recap a little bit on the 4 equations of motion that you have to memorize. Okay, 4 equations of motion. Okay, the first one is V equals to U plus AT. Okay, all the standard symbols apply lah. Hold on. Then the first one is V equals to U plus AT. V is final velocity, U is initial velocity, A is acceleration, and T, okay, and I'm purposely writing this T like this because I want to differentiate between the plus symbol. Okay, the second one, okay, is S equals to UT plus half AT squared. Okay, the third one is V equals V squared equals to U squared plus 2AS. And the final one is S equals to 1 over 2 U plus V T. Okay. Now, why are there 4 equations of motion? Why can't there just be one? Because if you look at this, there are 5 components to the motion. There is, of course, the time. Okay, there is the displacement. There is the initial velocity. There's the final velocity, and there's the acceleration. Sorry, the final velocity. Okay, and then there's the acceleration. Now, each of these equations is missing one thing of the 5. Okay, and that's why we need to have 4 equations of motion, because we don't need 5 things to count the motion. Okay, so this one, there is no S. In this second one, there is no V. The third one is no T, and the last one is no A. Okay, so the interesting thing is all the 5 got U lah. Okay, there's U inside all the 4. Okay, but everyone has a missing component, and that's why it's very important for us to know all 4. Okay, and I always, if I had taught you chapter 2, I would have actually forced you to memorize this lah. One of the very few formulas that I tell physics students to memorize is this 4, because it is a real waste of time to always refer to the front. It's so much easier to memorize. Okay, but since I didn't teach you chapter 2, then I'm just going to leave it at that lah. Okay, I'm going to recommend to you that you memorize the 4. But if you would rather memorize the lyrics to Permission to Dance, fine, go ahead. Okay, I'm not going to stop you. But you need to assess your priorities lah. Okay. Okay, velocity is 50 meters per second, and this is obviously the starting velocity. So this is U. The deceleration is 3. Okay, so A equals to negative 3 because it is decelerating. I think that's a very important thing for us to understand. When it is decelerating, the A will be a negative number. Okay, we want to find the minimum length. So we're talking about S, and the word stop or comes to rest or becomes stationary, okay, is very important. V equals to 0. So we have V, we have A, we have U, we have S. This is the Null T formula. Okay, which is the Null T formula? Dun, dun, dun. This is the Null T formula. V squared equals to U squared plus 2AS. Okay, V squared equals to U squared plus 2AS. Okay, you substitute correctly. 0 squared equals to 50 squared plus 2 times negative 3. Very important. Okay, that it is negative. Okay, and after that, when you calculate, what you will get is 416.67, I think. Yeah. Okay, so S equals to 416.67 meters. So the runway needs to be about 400 meters long, okay, in order for the airplane to stop. This is a very, very, very small plane, lah. Okay, it is only 400 meters. Usually the runways are much longer than that, much longer than 400 meters, in order for the plane to stop. Okay, do we have enough time to go through this? Okay, fine. Let me go through this now. So diagram 4.1 shows a boy of mass 60 kg. And so we're talking about momentum. Huh? Okay, momentum is defined as the mass times velocity. It's one of the very few formulas, one of the very few definitions where the formula is a definition. Okay, so momentum is the product. Product is hasil darab, okay, of mass and velocity. Okay, one of the very few definitions that the definition is the formula. The formula is the definition. Okay, describe in terms of momentum the propulsion of a rocket engine. Okay, so at this point, maybe some people are wondering, why is this diagram even here? If you're okay, actually, this is a question that's referring to something else, lah. Okay, that has nothing to do with this particular section of the book. Okay, it's actually a comparing question. Compare before and compare after. Okay, so you will actually find the same question in the conceptualizing section. Okay, in your this one. So propulsion of rocket engine. Let's talk about the rocket engine. Propulsion of rocket engine is you need to produce you know, I know the third and the fourth point is always the easiest lah. Okay, this produces a momentum backwards that will produce a momentum forwards. That is the kind of the third and the fourth point. Okay, so we would usually write okay, a large backward momentum is produced. Sorry, can you see? Okay, the large backward momentum is produced. Okay, so the rocket, okay, the rocket gains a large momentum forward because of the principle of conservation of momentum. Okay, this is the most important line that should be mentioned. Okay, because of the principle of conservation of momentum. That's why the rocket gains a large momentum forward. But this is only the third point and the fourth point. Okay, we know that in order for the rocket to go up, there must be a big momentum downwards. A big momentum downwards will produce a big momentum upwards. Okay, forward lah. Okay, fine, forward lah. So we call the downwards a backward momentum, upwards a large momentum forward. The problem is, how do we explain the large momentum backward? How is the large momentum backward produced? Okay, so this one needs, we need to remember this lah. Okay, just like how you explain different things. These are things that you need to remember and you need to explain. Okay, the rocket engine, the most important thing is liquid hydrogen and oxygen. Oxygen. Okay, liquid hydrogen and actually not just liquid oxygen, not just oxygen, liquid oxygen as well. Okay, both hydrogen and oxygen in liquid form, okay, is burnt in a combustion chamber. Okay, in Malay is ruang pembakaran lah. Okay, so when the liquid hydrogen and liquid oxygen is burnt, burnt in a combustion chamber, okay, this produces an exhaust gas, I think, yeah, okay, with high velocity. Okay, this produces an exhaust gas lah, okay, with high velocity. And so the exhaust gas backward, actually I should mention this, yeah. Okay. So the exhaust gas, just like the exhaust in your car, lah, okay, is produced backwards, but because this is a rocket, it needs to be produced with high velocity. It is really like an explosion. Okay, the hydrogen liquid and the oxygen liquid, when they burn, it's going to produce this huge amount of gas that produces a velocity backwards. And because there's a velocity, according to momentum, momentum is mass times velocity. You have the mass, you have the velocity, so the momentum backwards is going to be produced. And because principle of conservation of momentum states that before and after collision, before and after explosion, the total momentum is the same. So a backwards momentum must produce a forwards momentum. Okay, and that is in 4 points lah. Okay, this is point number 1, point number 2, point number 3, point number 4. Okay, how you produce the exhaust gas. And then what does the exhaust gas produce? Okay, and because of the velocity, there's the backward momentum, and because of the backward momentum, there's a forward momentum, and you need to mention the words principle of conservation of momentum. Okay, now I don't know whether any of these questions are coming out for your exam now. Okay, unfortunately I don't, but the underlying principles that we have studied today, okay, should be able to help you to answer the rest of this module. Okay, so the equations of motion, okay, all the graphs, all the graphs, the ticker tape. I spent a very long time on these graphs because actually the graphs are important. Okay, I would say that the graphs are very important, not just for the exam, but for you to understand in the whole chapter as a general thing. Okay, I think that's very important. Now, I just want to mention that this module is designed according to different sections. So the first one is called, what is this first one called? The first one is called pengetahuan, I think. Yeah. Okay, the first one is called pengetahuan. So all these are knowledge, comprehension, application. Okay, now the other three are conceptualization. Okay, astaga. Okay, conceptualization is the compare this, and then after that, state the relationship. The bigger the this, the bigger the that. That's conceptualization. Okay, go ahead and try those questions. I think those are much easier. Okay, and then the making decision is the one where I give you the table, then you have to choose the best one lah. Okay, and the one that I say, if it is a section B, section C question, answer in table form. And then lastly is the solving problem. Solving problem is you have to state the characteristics. You have to state the modifications and the characteristics and why we do those modifications. Okay, so the important thing is these three types of questions, okay, the technique to answer them is something that I have already taught you. Okay, and so you should have enough skills for you to, to answer these questions. Okay, and like I said before, I don't give the answers. Okay, but if you want to know whether your answer is correct, send me your answers and I will mark them for you. Okay, that at least tells me that you are studying for this subject. Okay, and so yeah.